So this is problem 5A1 from the textbook. This is how you solve it. So first we have our free body diagram of block G with its mass center, and it has a mass plane. And there's two supports at A and at B, which are horizontally distanced a length of B and vertically distanced a length of D away from the mass center. And for this, we have just a simple coordinate system, I and J. And then this is the free body diagram for B and A. Since the blocks are both spaced equally apart, they will have the exact same reaction forces. So to get started on this, first we do the summation of all the forces equals MAG. MAG of the mass center. And to start off with it, we have the force in the A direction plus the force in the B direction, all of this times the -1. And this is equal to the mass of the block times the acceleration in the G direction. So this is the force in the X direction. So now we got to do the force in the Y direction to get the normal force. So we simply write the equation Fy, sum of the forces in the Y direction, are equal to 0, because this is a neutral, it's in equilibrium there. And the force for this would be the normal force of A plus the normal force in B is equal to the mass of G times the acceleration of gravity acting on G. And now we have the unknown FAB, this is the friction force, and FB, and then the acceleration at G, these are all the unknowns, along with normal force and normal force. So we have 5 unknowns, and now we need 5 equations. Right now we have 1 and 2. So to get the other 5 equations, we simply have to write the normal force, at A times the distance B plus the normal force at B times the distance at B minus the friction force of A times D minus the friction force at B times D, so that equals 0. This will give us our third equation. And then our fourth equation, the friction force at A is equal to mu K times the normal force at A, and the friction force at B is equal to the coefficient of friction times normal force at B. This is our fourth and fifth equation. So now we can solve for all of our unknowns. And this is how you take all of your equations and input them to find all your unknowns. So we have FA and FB, so we can plug them into this equation and solve for it. So we got UK times NA times D plus UK times MB times D is equal to NA times B plus NB times B. I made a little mistake. That should be minus. This should be minus. My bad. Anyways, so we can infer from this problem, since NA and NB are equally spaced out, that NA equals NB. So we can just get 2 NA is equal to mg times the force of gravity acting on G. And then with this equation, we can infer that NA equals mg over 2, and that means that NV also equals mg over 2. Then with this, we can plug it into our friction calculations, and then we can get FA equals UK times mg over 2, and that FB also equals UK times mg over 2.
All right, class, Bill here. Ben so graciously gave you guys a fantastic way to solve this problem. However, I'm going to give you a bonus way when you're struggling on time on the exam. This is sort of the cowboy way to do it. So, we know with simple statics that we have a mass, aka a force times gravity, or mass times gravity, which is a force, in the downward direction. We have two supports up here. What can we infer? That the supports, so this is mg, the reaction force is at the supports, aka the normal force, is 1/2 mg. Oh wow, fantastic. Now Ben here so graciously wrote a free body diagram of the support. So we have the normal force poking up, which is 1/2 mg. And wow, we need to know the force of friction. But what is the force of friction? Well, if a block is moving, the force of friction is a coefficient of kinetic friction times the normal force. So we know that. So that's just equal to mu k times mg over 2. And that is for support B and support A. Wow.